Greetings, students. This is the fourth set of notes in the ES8 Freshwater Resources Unit. It's called Watersheds, ES 8.4. For this set of notes, you're going to want to write down everything that's in orange text. You can either type it or hand write it. Either way, it goes into your digital science notebook. So this set of notes is about watersheds. A watershed is a particular area of land that drains to a particular river or lake or estuary. And it's surrounded by an area of high elevation called a ridgeline. So on one side of the ridgeline, water flows into this river that's pictured here, and on the other side of the ridgeline is a separate watershed. Tributaries are shown here. They're different streams that feed the larger river. The headwaters are the beginning of the stream. The floodplain is the area that might flood every once in a while, and an estuary is where a river meets a body of salt water. So if you feel like I'm going too fast, you can pause the video and catch up. There's also a slide at the end that has everything you need to have written down. Watersheds. Each drop of rain that falls on a terrestrial surface, which is land, enters a watershed and begins its long journey back to a large body of water. If rainwater falls onto a permeable surface, the water percolates or infiltrates into the ground. So that's seeping into permeable surfaces. If water falls onto an impermeable surface, it runs off. So that's like pavement, moving along the surface until it finds a place to seep in or meets another body of water. Runoff can also happen when the ground is saturated with water. So when it's been raining a lot, the groundwater can get full, and then you'll have runoff on the surface. Water always flows downhill. It's important to remember that. Rainwater that falls in the mountains is ultimately destined to find its way to a large body of water such as a lake, bay, an aquifer, or ocean. We're going to talk a little bit here about rivers. Every river has a source, and this source is usually at a high elevation up in the mountains. The source can be a spring, a lake, or melting ice. The source of a river is also called the headwaters. Where rivers are moving, erosion is taking place. As sediments are transported by water, erosion continues. The size and shape of the particles is impacted by the amount of energy they are exposed to. Near the source, or the headwaters, rivers flow straighter, faster, and more downhill. This is a high-energy environment. These environments you find both large and small sediments moving along with the water. When the river reaches a flat plain, it starts to meander, which is moving side to side. It moves slower and wiggles back and forth along the landscape. This is a low-energy environment, so most of the larger sediments have settled out. As a river reaches the end of its journey, you will only find the smallest sediments that are still suspended, still floating. Here's an aerial view of a meandering river, moving side to side. And over the course of decades or centuries, a river's location can change. Sometimes there's a big flood and a river settles into a different pathway. This image is showing the different pathways that the Mississippi River has had since people started keeping track. So up at the headwaters in the mountains, that's a high energy environment where you have large and small sediments. And at the mouth, there's low energy and only small sediments. Stream dynamics. As you move from the source of a river at high elevation towards the mouth of a river at low elevations, a few things happen. The slope starts out steep and becomes gentle. Large sediments fall out of suspension early because energy is decreasing. Downstream, there are mostly smaller sediments, or fine particles. The river begins to meander, moving side to side in flat plains, creating oxbows. We'll talk about those in a moment. And when it reaches an estuary, the stream fans out into a delta. So oxbows are a particular kind of lake named after this. This is an actual oxbow that was used in farming. But an oxbow is a crescent-shaped lake. This is created by the meandering river. But sometimes they become detached from the river and then it's just a lake. As a river or stream moves across a landscape, that landscape is altered by the stream. Erosion over time can change the topography of an area. Rivers can cut valleys through the mountains. At lower elevations, a river will meander across a plain, making it flatter. So deltas and alluvial fans, these are two different things that look similar. A delta is when a large river reaches its destination, could be a lake, an ocean, or a bay, and deposits its sediment in a fan or cone shape. An alluvial fan is sediment deposited by a river in a fan or cone shape at the base of the mountains. So, is this an alluvial fan or a delta? This is a delta. It's a river meeting a larger body of water. Is this an alluvial fan or a delta? This is an alluvial fan that's at the base of a mountain range. Flooding and stream alteration. All rivers flood naturally and periodically. The area where a river might flood is called the floodplain. During periods of high flow, a river spills out onto its floodplain. When this happens, the landscape changes and the position of the river can change over long periods of time and many floods. Downtown Richmond is built on a floodplain, and you can see in the image here it is flooded many times. Humans intentionally change the path of rivers by building dams, channels, and flood walls. So if you've ever noticed, here's another picture of downtown Richmond when it's completely flooded, usually during a hurricane. If you've ever noticed, Richmond's got a flood wall. Well, that hasn't been there forever. But it protects downtown from these kind of floods, in theory. So when they think there's a danger of a flood, they shut all the doors and hopefully keep the river out. Built by the Army Corps of Engineers, maybe 30 years ago. I'm not 100% sure of the date right now. Here's a picture of a floodplain. You can see the slow meandering stream, but then that lighter colored area would be an area it could cover during a period of high flow. All right, let's talk about watersheds in the United States. Once again, a watershed is an area or ridge of land that separates waters flowing to different rivers, basins, or seas. Watersheds are separated by ridges, which is areas of high elevation. The Appalachian Mountains divide the United States, or the eastern United States, into two big watersheds, the Atlantic Ocean watershed and the Gulf of Mexico watershed. The Rocky Mountains divide the country into the Pacific and Atlantic watersheds. The area along the highest peaks of the Rocky Mountains is called the Continental Divide, or sometimes the Great Divide. So all the rainwater that falls to the left of that red line goes to the Pacific Ocean. Everything to the right of that line goes to either the Gulf of Mexico or the Atlantic Ocean. Each very large watershed can be divided up into smaller watersheds of individual rivers or lakes. So here's all the big rivers in Virginia. We are in the James River watershed in Richmond, the largest of them as far as what's contained in the state. And here's another look at the different watersheds of Virginia. So there's three big watersheds in Virginia, though: the Chesapeake Bay, the Mississippi River, and the North Carolina Sounds. So every drop of water that falls in Virginia goes to one of these three places. So looking back at this map, everything the James River watershed and above goes to the Chesapeake Bay. The Roanoke and the Chowan go to North Carolina Sounds, and then Big Sandy, the Tennessee River, and the New River all go to the Mississippi River and then the Gulf of Mexico. Here's another image looking at that same concept. One of three places every drop of rainwater that falls in Virginia. And it's important to know that these watersheds are bigger than what's in Virginia. The North Carolina Sounds watershed is mostly in North Carolina, but there's part of it that's in Virginia. And the Mississippi River watershed is enormous, and just a little tiny piece of it's in Virginia. Richmond's in the James River watershed, which is part of the Chesapeake Bay watershed, which is part of the Atlantic Ocean watershed. The Chesapeake Bay watershed crosses the boundaries of 6 states. Each state has different laws and regulations about water quality, but all of the water ends up in one place. So New York and Pennsylvania might have their own thoughts about what can be put into their rivers, but at the end of the day, it's Maryland and Virginia who have to deal with the consequences of what's dumped. So why might that be a problem? Each state has its own rules about what you can put in the rivers. Those rivers all flow to the bay. The end result is pollution from various places accumulating in the Chesapeake Bay. This leaves the bill for cleanup in the hands of Virginia and Maryland without accountability to the states that allowed the pollution. So here's what your note page might look like if you type it up. You're also welcome to handwrite it and photograph it. And that's it for the notes.